So once you need to download the training materials, they will ask you to log in. This will be your Huawei account. If you don't have one, you can register for a Huawei account, so it should be fine. Once you're logged in, yeah, just download these 2 training materials. If you are already part of the help community, you can go to the trainer zone and you can find your trainer training materials here, right? If you're not part of the help community, then yeah, you can download it from here, the public zone. So that's the link there. Is that all right with you guys? No issues, no issues. So I have 2 links. The other one is this link. If you want to put in this specific link, it's also the same thing. So you can go here, you can click learning, and you can download the training materials from here also. So it's either download it from the e.huawei.com/talent resources or download it from the Huawei, basically the Huawei Talent Online. Okay, you can see here, yeah, learning materials, training materials, lab guide, and all this stuff. You can download the training materials. The lab guide, we will do it a bit differently because we are not doing an online lab. We are doing more of a lab that I can basically let you download the, what do you call it, simulator, right? So you guys will be doing more of a simulation lab and all that stuff. Is that all right with you guys? So no problems on training materials. All the links are here. So
yes, no problem.
Okay. Also, I'll provide this other link here. Okay. So this is tiny URL. This tiny URL basically takes you to my Google Sheet. So, you can open up this Google Sheet here. Okay, there's an issue with my tiny URL. Yeah, okay, should be fine. So this tiny URL basically is my Google Sheet. You'll get all these links here. So I will be using these links throughout this course, where you can find certain like 3D tools or SPC and all this stuff. So whichever link I will use them all from here. If you have more links and all that, I'll put them here, no worries, right? Cool. So with that said, some background from you guys. So my background simple. My name is Praveen Nair. I'm a part of a company called InfoSight, an authorized training partner for Huawei. Right? I have years of experience in mainly in the network field. So I started off from network, and then I also did some storage and server stuff as an engineer. Then I joined InfoSight, and then I became a trainer. Certification-wise, I am certified for storage, I am certified for cloud, and certified for routing and switching, right? But mainly I do cloud nowadays, and some storage here and there, right? So you guys can access this Google Sheet and all that. You find all my details here. So like what's my email address, what's my name, and all this stuff. And of course, our class details, just a bit of the class details, small stuff, and the links, right? So I'd like to know from you guys, what is your background? I know you're all university lecturers here. I've got the list here. So do you have any background in storage, any background in network, any background in maybe servers or anything? Just to know, right? Doesn't mean you don't have background, doesn't matter, don't worry. It's just like I want to know, so I see the pace on how we go through the training, right? Maybe take it slower, maybe take it faster, certain subjects, yeah, depending. So do you guys all have background, storage, network, routing and switching, anything? No. So what are your expertise, sir? So maybe you guys can tell me what do you guys teach on, or what do you guys do? Don't worry. We have 5 days, so we will definitely see each other every day. So we're just trying to get to know each other, how we should move through the class. So prior to this training, you guys went for like any storage training or taught any storage class, or maybe network class, or even they call it server classes? Anyone? Don't be shy. Don't worry.
Okay.
Hello, sir.
Hello, good morning, Mr. Driver.
Good morning, sir. Good morning.
Yeah. Let me introduce myself first.
Yeah, go ahead. Go ahead, sir.
My name is Nur Alamsyah. Maybe you can call me Alam, my nickname.
Okay, sir.
Yes. As for my background, I already certified in Cisco networking, CCNA. Yes, but it was a long time ago in 2016.
Okay, no worries. No worries. Expired
yeah. But I still remember some of the material, some of fundamental or basic materials. And in my university, I teach advanced networking and multimedia system, which is there are some topic that relate to storage system.
Okay.
Yeah. So I really interest in this topic, and as my preparation to teach my student in university.
Okay.
And this is my first time to take a training in storage topic. Yeah.
Okay. Yes. No worries, sir. Thank you, Mr.
Yeah, thank you. Thank you, Mr. Yeah.
I'm just going to tell you straight the truth. Storage is a very boring topic.
Oh, yeah.
It's a lot of theory, okay? Yeah. So it is going to be boring. The first day is going to be very boring.
Yeah.
Then it'll just be a bit more boring in day 2 and day 3.
Yeah.
Until you do it, right?
Yeah.
Network is a lot more exciting. I know.
Yeah, no problem, sir. All right. Yeah, we will continue what we started.
No worries. No worries. Sounds good.
Yeah. Thank you so much.
Thank you.
Yeah.
So, anybody else?
Okay, sir. Maybe I.
Yeah, go ahead, sir.
Yeah. My name is Gandeva.
Good morning.
I'm lecturer in Telkom University in Bandung. Yeah, actually, my expertise is in Cisco. I have the CCNB. In Huawei, I have the cloud computing and routing and switching.
Okay.
And then my topic research is in computer security and a computer network.
Okay, sounds good, sir. Sounds good.
Thank you. Yeah.
So you guys, you have taken some Huawei certification, so good. Yeah. All right. So yeah, like I said, storage is going to be boring. So hopefully you don't sleep off during this training. So, but thank you. We'll go through it.
Yeah.
Anyone else? Don't worry. We still got a few days. Good morning. Good morning, sir. Good morning. Good. Okay. True. That's a lot of certificates already, sir. Thank you. Anyone else? Don't worry. No one else?
Hello, Prasen. My name is Idris Winarno. I'm from Surabaya, Polytechnic Electronic Engineering of Surabaya. My background, right now I'm teaching my student about computer network, and also have a CCNA certification, of Cisco certification, but long time ago also. And right now, my research topic right now is about resilient computing.
Okay, resilient computing.
Yep. I think that's all for my introduction. Thank you.
Thank you. Okay, I think we have someone else also. Anyone else? Cool. No worries. So I see most of you guys are from network background, right? Network, cloud, maybe computing, cloud computing, so virtualization, security, maybe you guys know the Huawei USG firewalls and all this stuff. Oh, cool. So storage, like I said previously, is going to be more on theory, right? So it's going to be a lot of theory, and I think lab is only about 1 day, right? Not mistaken. So it's going to be very, very boring. The first few topics, I have heard that people can fall asleep. So I generally, if you're going to teach this class later on, warn the students, right? Because they will definitely sleep. I'm going to tell you the truth. But once we get into chapter 2 and chapter 3, yes, for engineers, it might be exciting because they get to learn new theories and all that stuff. But if you are fairly new, if you don't have a background, like say in networking or in some other field of IT, it will start getting complicated, right? So I'll just show you some, do you guys know about the RAID protocols and all these things? So it can get very, very complicated, or it can be very simple, depending, right? So I'll start off with chapter 1, don't worry, we'll go through it step by step. If you guys have any questions at all, halfway during the lecture, you can just interrupt me, no problem. This is an open meeting, open conference. So anytime during the course, if you have any questions, you can either open your mic and ask that, or you can put it in the chat. I will be putting both on screen, so you can see sometimes my mouse moving here and there, because I'm actually checking the chat and also checking the screen. Also, lab-wise, truth to be told, there is a lab, but if you download the lab guide, they will tell you to do some virtualization stuff here and there. That will take some time. So what we are going to do is we are going to revert back to a bit more older lab. This one is using the simulator. So what we will do is download the Huawei storage simulator, and we'll see how to run the storage here and there. Okay. Topic-wise, if you go through, it's I think 5 chapters, 5 main modules. So you have module 1, which is storage technology and trends. This is the introduction, the boring one. Then we have module 2. This is a very, very important module. For exams, spend a lot of time in module 2, right? We will spend a lot of time in module 2. Maybe I'll take about at least about two or 3 days in module 2. Then you have module 3, which is also very important, which is a storage technologies in Huawei, at least, right? The good thing about this kind of classes is it doesn't only apply for Huawei. So the storage technologies that you learn in HCIA storage can also be applied for most of the storages out there. Okay, so that will be module 3. Then module 4 will be on backup and disaster recovery. So spend a bit more time here also. And finally, module 5. Module 5 is what we call the extra topic, right? It's there. The only way to know module 5 is if you do the lab. So that's why we'll be doing the simulator, right? So storage operation and maintenance, you have to have a bit of hands-on experience in that sense. But I'll tell you straightforward, module 2, module 3, and module 4 are the most important modules in this topic. if you want to study for exam, module 2, 3, and 4. Module 1 and module 5, yeah, you can spend a bit of time here and there, but you just have to read through and stuff. 2, 3, and 4, you spend most of your time, right? So if you're going to get ready for your exams and all this stuff, 2, 3, and 4, okay? 4, not that important, but yes, of course, you still have to know the disaster recovery and backup scenarios. But 2, 3, and 4 is a must, right? Module 5, the only way to learn through it is you could do some hands-on, right? So don't worry, I will show you where you can download the emulators and demo and simulators and stuff. So you can run around and play with the storage yourself, okay? Cool. So with that said, I think we have taken up about 20 minutes, so no worries. So with that said, we'll start with module 1, which I hope you guys don't fall asleep, right? Just saying. So module 1 will be storage, technology, and trends. And like I said, if you have any questions, straight away just ask me, put that in the chat, no issues. We have 5 days, so we'll get to know each other very well, don't worry. And at the end of the course on day 5, I will tell you some tips and tricks to get ready for your exam. So generally, we'll provide some help regarding the exam and all that, but we'll keep that for the last day, okay? So don't worry, we have 5 days to get to know each other. We'll take our time. Okay, so we'll straight away go ahead and start with module 1. I will take about 1 hour, 1 hour and a half or something like that. If I do exceed the time, I will say, okay, we'll stop here for now. We'll take a short break because it's not good to look at your computer screens 24/7. We don't want you guys to just spend 2 hours looking at your computer screens and your eyes get dry and all that. Yeah, not good for you guys. So we'll always generally take a break. What is the software we must prepare for the lab? So straight away, the software itself is actually a storage simulator. If you want to go ahead, I forgot which storage simulator we are using, but you can just go inside Google and download like a Huawei Ocean Store simulator. I think this is the site, not mistaken. Yeah, so I'll put this link there. So it's just a one-off product. Straight away, you download this product, you install, it runs as a simulator itself. So I'll put this somewhere in the links here. Okay. I used to have it somewhere here, but yeah. Storage simulator / demo. Okay.
Sorry, Pravin, for interrupt.
No worries, no worries.
Okay, the simulator running only for Windows, or it also running on Macintosh, Mac OS, or Linux?
This simulator only runs on Windows, sir.
Oh, okay, thank you.
No worries, no worries. Yeah. So you will download, I think you will download one of these simulators. I forgot which is the good one. So that one I will get back to you. So one of these guys will be using, and it will come up something. If I already have it installed, you should see something like this. Do I have it? No. So I will install it and show you guys. So maybe I'll do that tomorrow or something on how to install the simulator and stuff. It's pretty straightforward. You just download it, install it, should run, right? There will be some prerequisites you need to download, but yeah, should be fine. So you guys can go and try to download some stuff and see whether it works for you guys. Okay.
Sorry, Mr. Pravin.
Yeah, go ahead.
Which version that we have to download?
That one will frying drain a bit, because for now there's too many versions of it, I know. So I will get you guys to download 2 versions of it, but I will specify which version later on. Because the lab usually is only on about like Thursday or something, right? So don't worry about that, sir.
Yeah.
No.
Okay, thank you, sir.
No issues, no issues. This is cloud service. Okay. Okay. Yeah. All right. So in terms of lab, we will be using the simulator. However, if you want to do lab, the proper lab, you can download the demo, which is also actually here. So you can say Ocean Store. I think you'll have somewhere here. Yeah, you can download this Ocean Store, eStore, T3 and some stuff like that. If you have the trainer requirements, I don't know whether you can find it in the public zone. No, you can't find it in the public zone. Only under the trainer zone, you can download, of course, this Ocean Store. This is a VM, right? So you'll basically install a VM on your machine and you can run it like an actual storage. But this will eat up a lot of memory. So we tend to not use it on our own laptops. We tend to build a virtual machine on our other PCs and stuff. So we build a virtual machine on an actual environment rather than putting it on our laptops, right? So that are some stuff. So if you have the trainer zone, then go ahead, download it, no issues there. All right. So for the lab, don't worry, I will choose and give you guys, I think, 2 or 3 versions to download. Generally, we go through all the versions and see how they all work, right? So we'll start with chapter 1, module 1, chapter 1. It's going to be boring, and it is true, okay? So basically, they're telling you data is basically the main thing of storage networks. So what is the relationship between information and data? What is the function of data storage? Basically, this topic will define the definition of information and data, which is something that we kind of already know, but they put it in more of a storage environment here. So whatever we are going to learn is about storage situations, right? So you might have a different concept in network, but in storage, there will be a bit of a different concept here and there. We'll also go to the concepts, development history, development trend of basically storage and how it, or storage systems, right? So objective-wise on this topic, basically we'll go through what is the definition of information and data first, concepts of data storage, history of data storage, and finally development trends of data storage products. Content-wise, we only have 4 things to go through. They are not, well, let's say short. Some chapters are very long. This chapter is pretty short. So we'll go through data and information, then we go to data storage, we'll go to development of storage technologies, and finally development trends of storage products. So what is data in storage? It's simple. Data is basically the digital representation of, what do you call this? Digital representation of any kind of internet software you use, right? So any kind of application and all this stuff. So basically the format is 1s and 0s, right? So when you're sending an email, basically you're sending an email, you are typing it out in, let's say, alphabetical order, but the computer only understands 1s and 0s, right? So that's why I'm telling you, you don't have to keep focus on this topic, but yeah, just understand how it works. So data comes in many forms: emails, digital music, digital video, ebooks, even your video streaming and all that. Everything is in 1s and 0s. Basically, that is data itself. Right, then we talk about the actual thing. So data in storage, there are 3 types of data. You have structured data, you have semi-structured data, and unstructured data. So what's the key differences between these? Very simple. Structured data is data in rows and columns, right? Rows and columns simply meaning there is a table, there's a row and column, then you put your data in. That is what you call structured data. Semi-structured data is still using rows and columns, but maybe you add in some pictures and all this stuff, right? Unstructured data is totally like your videos, your MP3, your stream, your PowerPoint. So basically anything that is not in a structure, right? Semi-structure is basically meaning halfway there is a row and column still, but you're adding also like pictures inside the data table, right? Total unstructured data is basically data that is MP3, videos, and all these things. So in storage, there are certain protocols that use or best use. This is another thing I'll talk about storage. Everything is best, what do you call this? Best practices. There is no right or wrong way to use any storage, but it's just certain best practices. So I can tell you straightforward, like structured data, to make it confusing, structured data is something that we use more in block-based storage, right? Unstructured data we'll use more in file-based storage. Semi-structured also file-based, or you can use for block-based and stuff. But nowadays, mostly semi-structured data we use object storage or even file storage, right? So this is where it gets confusing. So it doesn't mean that you cannot use semi-structured data in block-based storage. Doesn't mean you cannot use structured data in some file storage or object storage. And doesn't mean, but best practice, right? A lot of things you hear in storage topic is best practice. There is no right or wrong way to do your storage, okay? But just understand there are three major data types. From there, we can move forward, right? So the three major data types: structured, semi-structured, and unstructured. Structured, rows and columns. Semi-structured, still using rows and columns, but you put it more in like a table. So how do you determine this in database concept? This will be your SQL database. This will be your NoSQL, right? And this will basically be videos or MP3s or some kind of audio document or something like that, right? But in terms of database, these are the two guys you will see, okay? And that is the three data types. Generally, we'll cater certain best practice for certain storage types on certain data. But doesn't mean that any storage can, every storage can be used for every data type, but best practice, best case scenarios, right? Just understand that first. Sorry. Okay. Data processing cycle. So it's all simple stuff. So like data processing cycle is a reorganization, reordering of data by humans or machine to increase their specific value. A data processing cycle includes three basic steps, basically input, processing, and output. So you can just understand like you're creating an email. You need some kind of input in an email. Then your email will be processing via some kind of protocol, SMTP or something like that. And then you get an output. You send the email to somebody, right? This is the process of data. You need input first. If you don't input anything, basically you don't have any data. After the data is input, then it has some kind of processing mechanism. So you input the data, once you create the whole table, then it makes sense. If you just input A and then you send it to somebody, somebody gets the email A, the flow doesn't know what to do, right? You just get the email A, oh, what does A mean? You need some kind of context, right? So this is where we are going with data and information. Just understand you have to have input, then you need some kind of method or process, and then that will be your output, right? Nothing much to look at, don't worry about this. Won't come out for exam also. This will come out for exam, right? So what is information in storage terms? So information is basically containing data plus some kind of processing, right? Do they tell you? No. Okay. So data plus some kind of process is information, right? So basically data itself, just put it in simple terms. So if you do a table, this is data, right? There's no meaning to the table. Or maybe you have something inside here, 0, 1, 2, 3. Doesn't make any sense. You have to have some kind of data redundancy or some kind of processed data. Basically, you add some context. So this one will be like ID, okay? And this will be like a number. So you put something like this, you know, okay, number 0, 1, 2, 3 is the ID of which person and all this stuff. So you'll have some kind of table that makes sense. Data by its own is just 0, 1, 2, 3 or 0, 1, 3 or something like that. Does not make sense. So data has to be processed to provide you information. Data by itself does not contain any value. Processed data is information. Okay, so information and data in storage, well, they have a very, very close relationship. Because in storage, the storage product doesn't actually understand what you're doing. You are the one who has to understand your data at the end of the day. So when you're inputting data, you have to do the input, process, and output. Data with some information or some kind of processing, that is basically your information. So information, if the exam they ask you, what is information? Information is data plus some redundancy, right? Data plus some redundancy or data process is information. This is basically the only question they ask you from data, information and data. So what is information? True or false? What is information? Information is data processed or something like that. You just need to know. Okay. I think do they have any like footnotes? Do you guys have the training materials? So double checking. So if you download the training materials, they should have some footnotes, right? Not too sure if they have footnotes here. Yeah. For you guys will be in a PDF version. The PDF version will also have the same footnotes. So no issues there. Just read through it. Mostly what will come out in the footnotes are the ones that will come out for your exam. Okay. So just to give you a heads up, read the footnotes properly. So what is information? Information is processed data. Information is data plus data redundancy, right? That's it. So data versus information. After being processed, data can be converted into information in order to be stored in some kind of storage or something like that. So data by itself has no meaning, right? Information is basically something that has meaning, that makes sense. Essence, basically your original materials are data and information is your processed data. Dependence, data never depends on information, but information depends on data. Without data, you cannot have information, but with data, you can or cannot have information up to you. Data by itself doesn't depend on anybody, but information depends on the data you have. Example, meteorological data or satellite image data. This by themselves don't make any sense unless you do some analyzing. If you do some analyzing, you can then predict the weather forecast. So this is basically the difference between data and information. Any questions so far? So if you understand this table, data and information is good, right? So basically just understand this table and you're good with any questions regarding data and information. Information lifecycle management, or what they like to call ILM. This refers to a set of management theories, like they say, and methods from the stage in which information is generated and initially stored to the stage where information is deleted. You don't have to put absolutely deleted, but yeah, deleted itself. So basically the life cycle of information is you have data creation, you create the data, then you have some kind of protection on the data, and then you have some kind of access method, migration, archiving, and destruction, right? So like take the email. So email itself has some value of data and all that stuff. You send the email to somebody, that person either keeps the email and all this stuff. So that we can just take a basic email here. So email sent to somebody. So that email sent to somebody will be sent in a secure environment. Usually you won't send an email to everybody in the world. You'll just send an email to some kind of a specific person. So that is where the email protection comes in. Basically, you know who you are sending to, the recipient has to know you, and then you can exchange email. For him to access the email, he has to have like a Google Drive or maybe Google account or some kind of Yahoo account or something like that. So there is an access method. So let's just call this Google. So maybe he has a Google account. Once he has a Google account, he has some kind of access method. So data protection here, we can just put like known for email, right? Knowing the sender. Okay, might not be the best example, but yeah, you can use other kinds of forms of data also. Data creation, basically you write an email, right? Data migration is basically the email phase. Let's say we are still using the email. So data migration, do you want to send the email out? After you receive the email, so the sender sends the email, the recipient receives the email. Do you want to resend or maybe forward the email? So you migrate the data not only from yourself to somebody else. And then do you want to keep the email? That's archiving. And finally, if you don't plan to keep the email, do you want to delete the email? So this is just an email sense. You can take it in other kind of sense also. So you can say like a file, a video. You create the video and all that stuff. Then you possibly have to do something with the video. So first, when you're sending the video and all that stuff, you will of course do some kind of content moderation. Let's say you're a YouTuber or something like that. So you'll do some kind of content moderation. You'll protect the data. You'll protect your video. You don't want your video to be taken off YouTube and stuff. So you'll do, in this sense, content moderation. Right? Then as a YouTuber or as a streamer or whatever, how is the method of accessing your data? So YouTube. YouTube is your platform, right? Migration of data. So people from other countries also want to watch your data, want to watch your video. So maybe you use something like CDN, Content Delivery Network or something like that. And then does YouTube keep your video? Right? And finally, if you don't want the video to be there, YouTube will allow you to delete your videos and stuff. So you can take this information lifecycle management for any form of data. Doesn't only have to be emails, doesn't only have to be, but there will always be a data creation, and then you'll always protect your data. So you have some kind of protection on top of it, like emails, SMTP and all this stuff. There will be some kind of access methods for your data. And then do you want to migrate your data? Do you want to send the data somewhere else that is under migration? Archiving, do you want to keep your data forever? Or finally, do you want to destroy your data itself? So this is the ILM. So far in the exam, no questions came out of this. Just to tell you guys, information lifecycle management, maybe the new version, they might come out with another question here and there. But don't focus on this too much. Most likely it's only going to be one question and stuff. Right? Any questions so far? The next one, yeah. Okay.
Sir,
Yeah, go ahead.
Can information be data again?
Can information be data again? If you delete off the redundancy, information can be data again.
Okay.
But basically, you don't want to delete off the data, so most likely you'll just leave it as information, right? If not, it does not serve any value. Like big data, right? If you take for that context, big data. Do you guys understand the concept of big data?
Little bit.
Okay. So no worries. So like big data is a bunch of data, right? So they're going to give you a bunch of data. You're just going to take all the data. Then you have to do some kind of analyzation of the data to provide some value. Else the data is useless. You just got a bunch of data and you're not doing anything with it. You're just taking up storage space. However, of course, if you want to revert back to data, you can just delete off the table and all that stuff. So it's a similar concept as this. So let's say you draw a table. You give a row and column and stuff. So let's say you put ID and then you put name. Right? So you'll say number 1, ID 001, name, let's say Alan. Right? So basically, if it's big data will just show you, okay, ID ID number 1, you put in some data inside. Then you have to analyze the data. 001 actually belongs to Alan, right? But if you delete off Alan, you just have ID 001, you don't know who the data belongs to. So you can revert data, you can revert information back to data, but it makes no sense. It can be done. But generally, you'll always move forward. So you'll analyze the data and provide it to somebody. So you'll provide it to, okay, ID 001 goes to Alan. This makes more sense. Else it's just a table with rows and columns. Makes no sense. Right? Any other question? No worries, sir. No worries.
Yes, sir.
Yeah, go ahead.
I would like to know, as far as I know, that multimedia data is the size is basically is very big, and yeah, usually it's very big.
Mm-hmm.
And then we have to compress it, so it's not so big. So we have to compress the data.
You're talking about WinZip and all that stuff, right? Okay.
Yes. So which stage in information lifecycle management that including data compression or
the lifecycle management.
Yeah.
No worries.
Yeah.
So the lifecycle management is just a theory in the back end. The compression and all that is basically technologies you use to make data easier to access. Okay. So this is just theory, high level theory stuff. So actual how you store your data depends. You want to compress it or you want to keep it as raw data. This is up to you. Does that make sense, sir?
Yes.
No worries.
Yeah. So maybe we can put it on data access, maybe in the data access stage. Yes, regarding
you can put it in archiving stage, I think.
Oh, archiving. Okay.
How you archive the data, right? So you compress the data, make it smaller, then you archive it.
Yeah. Okay. Yes. Thank you, sir. Yeah.
No worries. No worries.
Yeah.
Right. Then we move on to the next one, data storage. All right. So what is storage? So now we look at the actual topic. So we all understand storage. Storage is basically somewhere where you store something, right? That's the term of storage. We take storage into IT. Basically, you're storing data into some kind of hardware or some kind of device. So the devices can be like disks. Disks are storage device, right? So your your CD-ROMs, your DVDs, your floppy disks, your external disk drives, your USBs, your hard disk drives. All these are forms of storage media, right? So basically you're storing data into some kind of storage media. That is storage in what we will call a narrow sense, right? So we understand what is storage. But if we are looking at storage as a topic, storage in IT, we don't look at basically the storage medium. We look at the storage solution, right? So storage solution will be like SAN and NAS, right? Then you have object storage and all this stuff. The things we use to, or the systems and solutions and designs we use to provide a storage solution towards a customer, the end game. So what we are going to learn is this guy, storage in a broad sense, from this moment onwards, actually, right? So we're looking at storage in a broader sense, or storage in what we call a storage as a solution, right? So let's look into, this guy. So this narrow sense of storage is just like, we put something to store data inside a disk, or just some kind of storage medium. But if we go into a broader sense of storage, so this is what we are going to learn about, right? So first we'll learn about the storage hardware. So we'll start off with the hardware. So hardware will be like disk array, tape library, virtual tape library, host bus adapter cards, switches in your storage network, the cables and all these things, the actual hardware itself. Once the hardware is set up, once the situation is all right, then you'll have to install certain solutions or certain softwares. So you have like your storage management software. So for this guy, it will be like, for Huawei, it will be device manager, right? Device manager for Ocean Store, right? Snapshot and mirroring, you'll have Hyper Snap and Hyper Mirror. Okay, backup software, you will have basically backup and restoration, you call it, just backup, why not? Multi-parting, in Huawei, the multi-parting software, I keep forgetting, UltraPart, right? So you have, these are all the Huawei softwares. So if you want to go to the Huawei software here, these are all softwares in storage level products. So by default, nowadays, if you buy a storage controller, which is what we'll be looking at, you'll get all these kind of software. So you'll get some kind of storage management software on the controller. So you buy the controller for Huawei, you go inside a device manager, and you set the time, date, you'll set, okay, this storage belongs to who, if anything goes wrong with the storage, contact, email who, and all these things. That will be under the storage management software in terms looking at the whole storage. So the storage management software also acts like some kind of, what do you call this product? Some kind of alarm and reporting, alarm reporting product, right? So you'll get to see how much storage you have left, where do you have any disks are failing or any disks are going to fail. That's all under storage management software. Inside the management software, you'll have like smaller parts whereby you can do snapshot, you can do mirroring, you can do like replication, you can do your backups, and then you have some kind of multi-parting software which you need to install on the server so that the server doesn't see two storages and stuff. So we'll cover all this later on. But basically, you will have some kind of form of storage software. If you add both together, so both the software and the hardware together, you get to provide some kind of solution. So solutions are basically disaster recovery solutions or backup solutions itself. Backup solutions are done locally. Disaster recovery solutions are done off-site, right? So this is what we are going to learn, right? In this course, we'll spend more time regarding the storage software, the hardware itself, and how do you build your solutions, right? So just from this, if you guys have any questions, you can go ahead and ask. But generally, we'll be going through the hardware first, then we'll be going through the software, and then finally, how to build that solution together. Add both the software and the hardware. How do you build that solution in a general, let's say, customer environment, right? So these are basically data storage systems, right? So questions they can ask you like, okay, what is storage hardware? If you find any one of these as ABCD, just put them in as ABCD. So generally the exam will always be in objective format. Oh yeah, so you guys know the exam, you guys are all going to take the exam, right? Just wondering. Are you guys going to take the exam later on, or you guys don't have to take the exam?
Yes, it's compulsory.
Compulsory, okay. Right, so then do you know the exam format? Have you taken, some of you have taken Huawei exam before? For some of you, have you ever taken a Huawei exam before? HCIA, anything?
Yeah.
Cool. So for those who
Half of the class already are instructors in other subjects, so they must have experienced the exam.
At least, yeah. But I know some of you guys are more Cisco guys, some of you guys maybe done Huawei. So anyways, just to iterate the exam is objective, right, for HCIA. It's only 3 different types of questions, right? So the first type will be true or false. The second type will be single choice, right? And the third type will be multiple choice. So this is basically exam format. Objective 60 questions for 1 hour, 30 minutes, right?
Hello, Mr. Prophet.
Yes, go ahead, sir.
I'm sorry, I'm too late to join with.
No worries.
My signal is trouble, so I changed to place my home.
Oh, okay. So you had some internet connection issues. No problem. No.
I'm sorry.
No worries. Don't worry. You're still in chapter 1.
1 hour. I'm too late.
No, don't worry. It's okay.
Yeah. Okay.
I mean, at the end of the day, even today or tomorrow, some of you guys might have some work to do and all. So we are all working people. Don't worry.
Yeah. Okay.
No issue.
Yeah.
So basically,
Hello, Mas Brevin. This is Idris.
Yes, it
Can I
is.
ask for you? It's only 60 questions on the exam?
It's only 60 questions.
To pass the exam,
600
minimum, how many questions that we have to pass?
So it's basically, I think you need to do at least 43 questions to pass.
Okay. About 75%?
60%.
60%. Okay.
So the passing mark is 600 over 1,000. Different questions have different marking systems, I think. So true or false will be 15 marks, single choice 15 marks, and multiple choice, each one of them 25 marks or something.
Okay.
How about mock-up exam, sir?
Sorry?
About mock-up?
Mock exam?
Yes, it's same.
A mock exam is same, basically. So the exam that you do, the mock exam on the website. So if you do the website, sorry, I'll just clear this. So let me just open up. Sorry. So if you can go here, you can take this link. You can actually sign up for the mock exam. It's another way, it's a cool way, which one of the methods we use for the exam preparation. So if you go to this link and you go under learning, there will be a mock exam here, right? This mock exam is actually a 60 question exam. I think you have to sign in, yeah. So you can take this exam. You have 3 attempts every day. So that's a cool thing. So do keep this site, keep this link. You can do this basically every day, 3 times, right? It will be 60 questions for 60 minutes. So yeah, I don't want to start the exam now. So yeah. So you can try the mock exam here, no problems. every day you get three tries, sorry, right?
Okay, thank you, sir.
No worries, no worries. So your mock exam will be 60 questions itself, right? So yeah, like Stephen has just said, everybody is going to take the exam at the end of the day. So yeah, we have to get ready for exam. No issues. On the last day, we'll go through, or on Friday, I will tell you more tips and tricks on how to better go through your exam, better understand the questions. And yeah, hopefully you guys have all passed exams, so no issues there. So anyway, we go back into our topic. So we're going to learn about data storage. So we'll start from the hardware, then we'll go to the software, and then we'll build up to the solutions, right? So physical structure of storage. You must understand this is from the host point of view. So this is where your host is creating, your host here is a server. So how your server generates data. So they are splitting the data into both SAN and NAS, right? So these are storage technologies we'll learn later on, SAN and NAS. We'll go through them one by one so you guys can understand how the storage works. There are different types of storage systems, but generally we'll focus more on SAN and NAS, or which is called storage area network and network attached storage, right? So how storage area network works, generally, your host will send data via certain networking devices. So it can be Ethernet switches, can be fiber channel switches, depending on what kind of environment you're using. And then you'll go into a storage controller. So this whole thing at the back here is actually what we call storage controller environment. So generally, this whole course is about the storage controller itself. Okay, so the storage controller for SAN environments, you will have a front end controller board. So this is the guy that connects to the network devices. So you'll have cables connecting to your network devices and stuff. Inside the storage controller, we have something called a cache. A cache is basically where your data is saved. So how the storage system works is a bit different. When data is sent via the host through the network device, so data is sent via the host through the network device, comes to the storage controller, data is actually saved on the cache. Once the data is saved on the cache, so your data is here, once the data is saved on the cache, the storage controller will tell the host, okay, your data is saved. But in actual fact, the data is only saved on the cache, right? So you'll generally, when it's saved on the cache, it's already tell the host, okay, your data is saved, you can go and do other things. After that, it will flush the data. So this part they don't see. So basically here, they will flush the data. Right? So this is how it actually works. So why storage controllers are so powerful? Because of the cache itself. You save the data into the cache. The cache is more random, volatile memory. Hence, it saves data faster. Once the data is saved into the cache, it will tell the server or the host, okay, your data is already saved into the storage. And then the host can go and do other stuff for its application. So maybe cater for more users or something like that. And once that is done, it will slowly flush the data into the disks. Once it's flushed into the disks, then you're actually saving it into your actual disk. So this process will take this process is only after the data is saved into the cache. Okay. So if you go through that again, when host sends data, the data goes through the network devices and all that stuff, goes through the front end controller board, and it's saved in the cache. Once the data is saved into the cache, the storage system will reply the host, okay, your data is saved. Okay, no problem. So the host then can go and do other things, service applications, service other clients or whatever. Then the storage controller will slowly flush the data into its disks. So this is how the storage system works, right? Generally,
Sir,
yeah. Go ahead.
the cache is special cache or is just RAM?
Sorry?
The
It's,
cache.
you can count it like a RAM, but it's generally not RAM. It's a special cache in some sense. So
Okay.
Yeah.
So it's spared from the RAM, yeah?
Yeah.
Okay, thank you.
Generally, okay. So if you go online and check for storage controllers and all that stuff, storage controllers are very expensive. Why they are expensive is because the cache, right? The bigger the cache size, the larger the cache, the more expensive the storage controller, right? So if you have a storage controller that has 50, 60 terabytes of cache, generally it'll be a bit more expensive compared to somebody that has 1 terabyte of cache, right? So that's how it works. And then you have, of course, the file system method. The file system method, we'll go through it, don't worry, one by one. But I just wanted to tell you about the SAN storage. So when we go into the SAN storage topic, you'll have a bit more understanding because they don't talk much about how the cache flushes the data into the disks. Okay. Any other questions? Cool. So this whole thing is the storage controller itself. This is the storage system that we're going to learn about, right? So basically we're going to learn about how the front end controller looks like, how the back end controllers, how we connect the disks, what are the back end controller boards, what are the types of network we can use, all these things. So this is physical structure. Data storage types, you have, of course, storage itself. You have internal storage. You have external storage. Internal storage, basically, you just call it DAS also, right? Internal storage is also a DAS device, right? External storage, you also have external DAS. Then you have fabric attached storage. Fabric attached storage, you either call it a storage area network or network attached storage. So I'll just give you a bit more context here. So DAS is direct attached storage. FAS here, just fabric. SAN is storage area network. And this is network right? So you have different storage types. Internal storage by default is usually DAS products, internal storage. So what's the difference between internal and external storage? Or how do you clarify internal and external storage? You got a server, you buy a server, so you just purchase, let's say, a server, right? So you have a server here. When you purchase a server, of course, you purchase some hard disks, right? You purchase hard disk 1, hard disk 2, as many hard disks as you can get. Generally, these are internal storage, right? Internal storage, that means basically inside the server. Forgive my handwriting, but yeah, these are internal storage, right? And then your server, maybe you have bought as much disks as you can, you have some problems, you have maybe attached about like 20, 30 disks, still not enough space. You generally have the server attached to some kind of external storage box. So you buy like an external hard disk or something like that. The concept, this guy is an external storage. Right? So let me ask you this. A USB stick, is it an internal or external storage device? So if you plug a USB into a laptop, is it an internal or external storage device?
External.
External, right? So that's the concept, simple. So anything that you plug into something else, external. Anything that you already have inside like your laptop and all this stuff, that is internal. External storage, you have direct attached storage. Direct attached storage is like your USB. You directly attach it, you use it. External drive or external disk is another form of direct attached storage. You plug it in and then you use it. That's it. So that is direct attached storage, one-to-one storage. The problem with direct attached storage, we'll enter that later on. So we'll talk about the advantages, disadvantages of all three. Right. Then what is storage area network? Basically, storage area network is something like this. So you'll have your server, you'll have a switch, and then you'll have a storage controller, right? So they are all going to be connected together via a certain network. And this is your storage area network. Okay, then it starts getting a bit more weird. So what is network attached storage? Network attached storage is basically your server, but also your switch, and also the storage controller. Okay, so what's the difference between storage area network and network attached storage? So let's put it here. So it looks the same, network attached storage and storage area network. So let's just put this as SAN and this as NAS. Simple difference is NAS uses your LAN or your local area network. SAN does not use your local area network. SAN will either use fiber channel or right. So SAN does not use LAN. So basically, if you're using LAN, that means you'll have some kind of IP address, right? And if you understand the concept, simple, file server. So when you go to work, you access your file server, you upload, download certain files in the morning, right? That file server concept is a NAS concept. So file servers are basically NAS, right? However, if you have like database and all these things, if you have huge MySQL database, huge Oracle database and all that, generally databases run on SAN. File servers run on NAS. So NAS, you can just say it's an optimized file server. Storage area network is the network behind your servers. As network engineers, or if you are familiar with the network environment, generally, if you work in a company, you're just working with network environment, you will never see a storage area network itself. Only storage engineers and server engineers will see the network behind the servers. But for network engineers, we will still understand the concept of a NAS, whereby we'll say, okay, some storage guy will come to you and say, I want to connect this server to the LAN. Now I want to connect the storage to the LAN and all this stuff. So generally you'll have an IP address, it'll run on your local area network and stuff, right? But SAN will never run on your local area network. SAN does not have IP addresses. SAN has something, either you use Ethernet frames, which is ISCSI, or you use fiber itself, fiber channel. The protocol generally used in SAN is SCSI. Okay, any questions so far before I just delete off the stuff?
What the advantage of SAN vs NAS?
Sorry, sir, go ahead.
What the advantage using SAN or NAS?
Attributes. So
what the advantage of the SAN or NAS?
What advantage? Simple. So SAN, basically the server and the storage can talk to each other without the LAN network talking to them, right? So you don't have the problem of the LAN congestion and all these things. So if you're running on like a normal network, the LAN environment, a local area network, you'll have user traffic, you'll have all the other kind of traffic, right? But in SAN network, the server and the storage is in their own network. They just talk to each other, and basically it's a much more faster, much more durable network. However, network attached storage Because it runs on the LAN, it has an IP address. So theoretically, if you have an IP address, you can connect to it from anywhere, right? As long as there's routing in between, you can connect to it from anywhere. So hence, NAS boxes are reachable via your network, easier to reach. SAN network is an isolated network, even though it's a high-powered, more stable network, but it's behind the servers only. So generally, a user, so like say a normal user, cannot talk straight away to the storage. He has to go through the server has to contact the storage for him. However, a normal user here, so just normal user, can straight away jump into the file server. Those are subtle differences here and there. Any other questions, sir?
Sir, question from previous slide.
Okay, let me just clear this. All right.
From the left side, is it just SAN with front end and back end controller? How about NAS? It is the same?
It's the same.
Okay.
So here they're just telling you extra stuff like your storage application, storage management and stuff. But generally it's the same. If you're talking to a storage box straight away, you will still like even NAS, when the user sends information to the NAS gateway will talk to the cache. You'll save data into the cache, and then yeah, same stuff.
Okay, thank you.
No issues. Any other questions? Cool. Right. Then we go into data management. Let me see what time it is. Okay. So maybe we'll take a break shortly, but don't worry. I tend to talk a lot during this stuff because, yeah, storage, a lot of things to talk about. So we are talking about the evolution of data management technologies. So this is something that you just have to remember, sad to say. So we started off with manual management, card, paper. This is super old. This is something that you don't even need to remember. It's just talking about total manual. Then we moved into the file system management, whereby we have like tapes and single disks. So this is like a single server. Then we have dedicated storage device. This is where the emergence of the SAN network comes in. You have server talking to switch, talking to storage device. Then nowadays in the internet environment, you'll have distributed storage device. Distributed storage is a bit different. So it's like server talking to multiple storage, right? This picture is a bit bad. Okay, maybe just put 1, 2, 3. Okay. So distributed storage, basically all the back-end storages here, you only find this mainly in cloud, right? So this will be most likely in cloud networks, because cloud vendors and all this can sustain or basically have more money, right? So your server will talk to multiple different back-end storages, and your data, when you save into the storages, you're actually saving like 1 MB of data here, 1 MB of data here, 1 MB of data here. So you're saving data across the back-end storage. That is what you call distributed storage. Distributed storage is where you can see in your basically how the cloud providers provide you 99.99999 maybe about 99% reliability. Right? So to achieve this 99.999% reliability, usually it's about 11 times 9 or something, they have to use distributed storage. If they use dedicated storage, they cannot achieve this 99% or 99.999% reliability. Something that you just have to know, right? How distributed storage works, if we start talking about it now, probably we'll finish by Thursday, right? There's a lot of topics. So we'll go through the basic environments here and there, but you just have to know it on a high level. Here we are mainly focusing on this guy, right? We are mainly going to be focusing on what you call traditional or SAN and NAS environments. Distributed storage environments, if you go to like cloud service, cloud computing and all that, then you understand distributed storage. Before that, any questions? I know somebody had a question just now. No issues? Okay. So generally, when you talk about distributed storage, you'll have like your 3 data copies, you'll have your distributed backend environment, you'll have some kind of software to virtualize the storages and all these things, right? But generally, that's where you see distributed storage. Distributed storage mainly for cloud. Or huge companies with a lot of model and all these things, they can build a distributed storage environments themselves. Petroleum companies, huge financial companies and all these things. But for normal, small and medium enterprise organizations, you will rarely see them go with distributed storage itself. Okay, cool. Any questions before I continue? Right? No worries, no worries. Okay. So data storage application. So data storage application, basically, you have the data generation people, so like our users. So all the users, the employees and all that, they will generate data. The application servers or your email servers or your file servers, these are the guys who will do data processing. And then you have your storage controllers. So this whole thing is your storage controller. So this guy probably will be your storage controller. And this will be like your disk arrays, right? Extra storage space. So generally all the servers and all that stuff, they will send data to the storage controller. The storage controller will then, if it doesn't have space inside its storage controller itself, it will send it to the disk arrays, right? So yeah, storage controllers are the ones to do data management nowadays. Very less environments, very less companies actually do the data management on the servers itself. The servers are just a medium for application processing. The actual data is saved into the storage. This is also how you build like cluster environments and all this stuff. So you're going to build like a cluster servers, like you say you have 4 servers or 3 servers catering for the same application. Those servers most likely will connect to the same storage at the backend. They will have some kind of cluster environment. So MSES or Microsoft cluster and all these things. But generally, this is how it works. So less and less people actually use the servers, unless it's a small company, to do the data management. The servers are just there to cater for the application, to cater for the front end, the web page, and all these things. But the actual data is actually stored in the storage controller itself, right? So this is something when you're working in a network environment and all that, you don't really realize, right? If you're a network guy, you'll think like, okay, just data sent to the server saves the data. Actual fact, the server actually saves the data in a storage controller. And tell you the truth, the most expensive component usually in the network is usually the storage controller. A storage controller by default, the cheapest one, or a good cheap one, you can get 20,000 USD. One storage controller. There is a reason why it's so expensive, but yeah, generally it's one of the most expensive component in the network itself, right? Doesn't matter if it's a file server or if it's a block-based storage. Generally, storage controllers are very, very expensive. So here they're just telling you, okay, users are creating the data. So users send the data to the application server or the database server or whatever, right? The database servers actually store the data in the storage controller. If the storage controller is just a controller by itself, so there are 2 different types of storage controllers. If it's just a controller box, it basically doesn't have any disks and all that stuff. The storage controller will send the data to the disk arrays. And the storage controller is just a cache, right? So this is where they do the caching. After the data is saved into the cache, generally flush it out into disk arrays. And yeah, maybe later on you want to do some archiving and all that can be done into offline storage, right? But this is basically data management phase. So this course, once again, we are going to talk about this part, data management itself. Okay. Any questions? Cool. Right. Maybe before we go into the next part, so let's see how much more we got. Here we have quite a few things to go through. So maybe before we start into the next part, do you guys want to take a short break?
Yes, sir.
All right. I understand. No worries, no worries. So we'll take a short break. No worries. We'll come back and go back into the storage architecture, and then we'll complete the chapter there. So on here, right. Right. So current time for you guys will be 10:25, right? For me, it's 11:25. So you guys will be it's 10:24, but let's just put it at 10:25. We'll come back at 10:40. Is that all right with you guys?
Yes. I think.
No worries. Cool.
Yeah, I think fine.
Yeah, I think that's enough. Break.
Yeah, no worries, no worries. So you'll take a 15-minute break and then we'll come back. All right, web file is this PPT. So if you have the account, you can just go to this this guy here. Where is this? Training materials. Okay. Yeah. So you can go to this website. Once you enter this website, so it'll look something like this.
Okay. What file number or file name?
File name will be HCIA storage. So you can just, and this is the site, right? So you just click HCIA, click storage, and you should see this training materials.
Okay.
But make sure you download version 4.5.
Mm-hmm.
Yes, you can combine SAN and NAS. Usually, if your NAS is not enough storage, you will then propagate it into a SAN environment. So the NAS can increase. So that's a complexity there, but yeah, you can generally combine SAN and NAS. Nowadays, most storages come with SAN and NAS included itself, storage controllers itself. Like Huawei generally caters for both SAN and NAS. So no issues there. No worries, no worries.
Hah? Ada.
All right. Sorry about that. We are back. So we'll continue on from where we left off. So topic 1. Okay. Right, so we'll go into the development of storage technologies. So we'll enter storage architecture first, then we'll go into storage media and interface protocols. So history of storage architecture development. So we'll start off from the old days, which is the traditional storage. Have you seen these guys before? These guys you can only see in the museum now. So basically these are museum stuff, right? External storage, this is something you will still see. Storage network is widely used. And of course, you have our distributed or cloud storage, right? So do you guys know where are the disks here? So this is the disk last time. Basically, you see this thing here. This is the full disk. So each of this is like a disk, right? So these are the old guys around 1950s. This is what we call the traditional storage. It's something that you generally do not see anymore. However, this external storage, this architecture is still seen. You will actually see Huawei storages actually look very, very similar. This is a Huawei storage. So you will see something like this. These are external storage devices, or what we call disk arrays. Right? Storage network is where you have your storage controller and all this stuff. So this is mainly SAN or NAS. Sorry. Or NAS. And of course, our good friend distributed storage in the early 2000s, when cloud came about, that's where you see distributed storage architecture, right? So nothing much to look at this point of view. Just, I do not know if they'll ask you in the exam regarding date and whatever, but so far I have not seen any questions asking you, okay, in 1950s, what was the traditional storage architecture? Or in 1980s, what is the traditional storage architecture and all this stuff? Generally, they don't ask you that question, so don't have to worry that much. However, from disks to disk arrays. So this is a logical version of your disk. Inside your server, you have your CPU, you have your random access memory or RAM, and then you'll have your disk, which is your storage space. Okay. Then in the early days, basically servers, they used to have additional storage space by attaching what they call disk arrays. Right? Disk arrays have the term known as JBOD. JBOD is as simple as just a bunch of disks, right? So generally what you're doing is, if you're running out of space on your server, so if the server has no space, no more space to add additional hard disks, you'll attach a disk array, which has, of course, multiple disks you can attach to a disk array, but that is just basically just a bunch of disks. Why they call it just a bunch of disks? Simple. In actual fact, it is just adding more disks. In terms of the usage and all that stuff, the servers is still using its own CPU, its own RAM to do all the processes. So basically, there's very heavy load on the server. Right? Because the server not only has to cater for its applications, it also has to manage its storage, where to find the file, what kind of file is it, where is it saved, which block, which, and all these things. So basically the server has very high load, hence the emergence of what we call a storage array. Okay, so a storage array, basically the server still has disks, so but now the disks are just used to install the application. So here is where all your applications will sit. Application, your front-end database and all that stuff. But the actual data is actually sent to a storage controller. So the controller is now taking up let's say disk management, right? So now the storage controller is helping the server basically manage its disks, manage the storage space. Okay. So what happens is when the data is sent to the storage controller, initially it's sent to the cache. So the cache here. Once the cache is, well, let's say the data is saved into the cache, the storage controller then sends it to its disks. So it might put the data here, it might put the data here. Doesn't matter because the storage controller is now taking up the process. The server can just mainly just cater for the application now, and the storage controller will cater for the backend data, right? So the server doesn't have to worry about where is this data is saved, how is the data going to be saved, what kind of file format, and all these things. All that is taken care of by the storage controller. Hence, a lot of processing power is alleviated from the server itself. Like if you run Windows, and if you're running a Windows server, you don't have extra storage and all this stuff. You can see the CPU utilization suddenly spike when you're trying to install a new program. The CPU utilization will spike, the memory utilization will go high because the server has to try to say, okay, where to save this file. You're installing like a new application or installing like a huge, let's see, animation software, or you're doing some kind of animation and all these things. All the data that is generated by the animation software has to be saved somewhere. So in that sense, the server is doing everything. Now, if you run like animation software and all that stuff, the server just have to mainly cater for the animation software, where the data is actually taken care of by the controller. So it takes off so much processes from the server itself, making sure that the server doesn't have to do so many things at the same time, eliminating a lot of process functions. This is what a storage controller does. So this is the emergence of the storage array. This is what we're going to look at, okay? From separation to convergence. So separation basically meaning last time when we have disk arrays or storage controllers, sorry, you'll either have a SAN controller or a NAS controller. So if you're running file storage, so and block. Okay. So if you're running file storage, you will buy a NAS box. Then suddenly at some point in time, you realize you need, you also want some kind of block storage. You will then buy a block storage service or block storage controller. That is the old days. Nowadays, everything has been converged. So Huawei products or Huawei storage controllers are mainly converged controllers, whereby you have both NAS and SAN, right? So NAS, still you connect the switch via network or LAN to the storage controller, and SAN you can still connect like backend servers to the storage controller this way. But basically this is a converged product now, right? So that's what they're trying to tell you here. So it's basically cheaper for you, right? In the old days, you had to buy either one of those. If you want to run file, you'll buy NAS. If you want to buy run block, you'll buy SAN storage. But now, because of the converged system, you can either run SAN or NAS on the same controller, right? All Huawei controllers are mainly converged controllers, right? Any questions? Simple stuff here, don't worry. Right. Distributor storage. So this is something we have to spend a bit of time. Let's just talk about this. So distributed storage, you have both your front end and back end network. In actual sense, distributed storage is just a server. So basically you have multiple servers So it's server with storage and disk and all that inside. You'll have your disk, you'll have your servers. So it's not a storage controller in that sense. It's just normal servers, right? You'll buy the servers, you'll attach them in a network, and then you'll run some kind of software. The software will then virtualize all these guys. So the software will basically virtualize all these guys and create a, what do you call this? A virtual storage pool. So basically, how many servers you have in your distributed storage network? So let's say this guy has 10 terabytes of storage space. Sorry. So maybe this guy has 10 terabytes, this guy has 10 terabytes, this guy has 5 terabytes, and this guy has 10 terabytes. So in actual sense, you're virtualizing 35 terabytes of storage space, right? So you're just combining in one big distributed or one big storage pool. To do this, you will need to have some kind of, let's say, virtualization software. So in Huawei, the virtualization software is called Fusion Sphere, right? Inside Fusion Sphere, you will have Fusion Network or Fusion Cube. You'll have Fusion Storage, and you'll have Fusion Compute, right? So these are the three things inside Fusion Sphere that caters for virtualization. Fusion Sphere is the main product. It's derived from, if you want to see a cloud environment, it's derived from OpenStack, right? So basically you use Fusion Sphere derived from OpenStack environment to virtualize all the storages, all the physical storage into one big storage pool, all the network into one big network pool, all the compute or the CPU and memory and all that into one big compute pool. So how does distributed storage save data? Distributed storage follows the 3 data copy concept. So let's just put that in perspective. So when you're saving data, so let's say you have 100 terabyte, let's say 2 MB of data, right? 2 MB. So 2 MB of data, you're actually saving the data not in one location. How the distributed storage software works, 1 MB will go here, 1 MB will go here. So basically meaning you have your data itself is distributed. But how they keep the data highly available and all that stuff is using the 3 data copy. So for every 1 MB of data, so for every 1 MB, they will save the data in 3 locations. So they'll save it here, they will save it here, and they'll save it here for 1 MB, right? And then if you have data 2 coming in, for every data, they will save it into 3 locations. So data 2 will be saved here, will be saved here, will be saved here. This is for every 1 MB. So if you take 100 MB of data, your 100 MB of data is actually saved into 3 spaces or 3 physical storages, ending up to be 300 MB of data, right? Because there's 3 copies of the data. This is how you achieve the 99.9999999%, right? Because as long as your data is located in one of the physical storages, so even if this storage goes down and this storage goes down, you can still find data 2 and data 1 here. Only until all the 3 storages go down where your data is lost. So physically meaning 3 servers have to break down, or 3 servers containing all your 3 data have to break down, and then your data is lost. So this generally never happens, right? Unless, yeah, if power outage, everything goes out, then yes, different thing. But generally your data will not be lost because it's saved into 3 different locations at the same time. And every time you're saving data, you're not saving for each 1 MB of data, you're saving it into different physical locations. And then you're multiplying that by 3, so you have 3 copies of the data. This is generally how distributed storage works. Any questions? Okay. So we'll just...
What the difference with cloud storage?
What's the difference between normal storage?
What cloud storage?
Oh, this is cloud storage, sir. So basically, this is basically found on the cloud. Distributed storage is usually found on a cloud environment. You will rarely see this on a normal enterprise environment. Does that make sense, sir?
Okay.
Yeah. So this architecture is used generally for cloud environments. Huawei Cloud, Microsoft Azure, AWS, and so forth. Right?
Okay.
Yeah. So SAN and NAS is the environment that we use on local environments. Distributed storage for cloud. So physical resources are organized using software to perform high performance logical storage pool, not only storage pool, compute pool and network pool also, but we are mainly talking about storage, ensuring reliability and providing multiple storage devices. So every time you save data, you're saving data into different physical environments. Generally, distributed storage scatters data to multiple independent storage servers in a scalable system structure. It uses those storage servers to share storage loads and uses location servers to locate storage information. So generally, when you're saving data here, you'll save data into objects most of the time. So objects will carry like metadata, and a key. Don't worry, you don't have to remember this. I'm just giving you more information here. So when you're sharing something into like cloud storage, like Google Drive and all these things, Google Drive basically use object storage. Object storage is built on distributed architecture, right? So they use the metadata and the key to determine, okay, what is the data here? So the key will determine, okay, the data is located here, here, and here, right? That's how it's done. Virtualization. Storage virtualization is basically the concept how you build up your distributed. So this is the physical environment. This is the logical environment. So storage virtualization consolidates the storage devices into a logical resource, thereby providing comprehensive and unified storage services. Unified functions are provided regardless of different storage forms and device types. So to achieve the distributed storage environment, basically they don't care what kind of servers you're using. So you can have multiple different servers. This is also the topic of how AWS used to run its environment. Basically, you can buy any servers off the shelf. So any servers, you guys go to a shop, you just buy the server, you buy multiple servers, you add it into the, or you install the software into the servers, and then you virtualize all the resources, right? So basically just combining all the resources of the physical devices to provide a virtual storage pool, a huge pool of resources. Of course, you'll have some kind of management and all this stuff. So that virtual storage pool is then provided to the client or the service, right? As what you call LUNs. Or you can provide it as object storage or whatever, right? So basically, it's storage virtualization concepts. Virtualizing physical storage media into a huge storage pool. That is the term of virtualization. Or that's basically the concept of virtualization itself. How it works, here they're using, for Huawei, we use Fusion storage, right? Fusion storage is the one that helps you virtualize your physical resources into a storage pool environment. So cloud storage, the cloud storage system combines multiple storage devices, applications, and services. It uses highly virtualized multi-tenant infrastructure to provide scalable storage resource for enterprises. The storage resource can be dynamically configured based on organizational requirements. This can only be done if you have a lot of storage. So to provide this kind of storages to people, usually it's only a vendor environment, right? You can build up, you can build up your own cloud environment, you can build up your own public or private cloud, but it will cost a lot of money. However, because like Huawei, AWS, and Amazon and all these guys have that capital, they have that hardware and all that, they can provide this storage service to people where they can dynamically adjust the resources. At any time you want to increase the storage, at any time you want to delete the storage and all that, that can only be provided mainly by cloud vendors. It doesn't mean that nobody can. It doesn't mean that only cloud vendors can do it. You can also do it, but you have to have the capital. And also in cloud storage, they provide like Huawei Cloud. They provide block storage as something called EVS, file storage as something called SFS, and object storage as something called OBS. Don't have to remember, but if you're going to planning to take like cloud service classes, then yeah. So basically they'll virtualize any block storage environment into something called EVS, and then provide it to either your legacy applications or your new generation applications, no matter. But they will just provide the base product or what they call infrastructure as a service and provide it to you. Okay, so this is a term of cloud storage in some sense. Any questions? Cool. Okay, the cloud storage. Oh yes, for the exam you have to remember these three things. Yeah. Converge, elastic, and open. They will always ask you what are the characteristics. So the question will come up with characteristics. Characteristics of cloud storage, right? They ask you this question, what is the characteristics of cloud storage? Can be a multiple choice question or can be true or false kind of question. You have to remember cloud storage is always converged. So you have converged block, file, and object. It's elastic. So that means you can scale up or scale down. And it's open. You can basically access it from anywhere. It's cloud environment, right? All right, so that is the architecture of storages. Now we'll move into storage media. So media will start with hard disk drives. Hard disk drives basically tend to start from what they call the giant disk. So if you take this IBM 350 RAMAC, you put it into, let's say, Google. Yeah. If you look at the image of this disk, this is the IBM 350 RAMAC. This used to be what our disks look like in the old days. You can very rarely find them now, but of course, yeah. Not only that, the actual disk space of all these disks, not actually that much, right? But this is how disks used to look like. Then we start moving on to the IBM 3340. So we move here. If we go to IBM 3340. Started going a bit smaller, still huge, but these are like 14-inch disk drives. Then we move on to our good old, is this 8-inch disks. So this is where it started getting smaller and smaller, right? 8-inch disks generally are not used anymore. Now you'll only find 5.25, 3.5, and 2.5 inches. You'll also find the 1.8 inch. Huawei does use the 1.8 inch for certain devices, but generally Huawei uses 2.5 or the 3.5 inch, right? If that's on the cheaper side. But if you're going like NVMe disk and all that stuff, yeah, these are the guys. So you can see the size getting smaller and smaller, right? But the storage size is actually getting bigger and bigger. Now, I think what's the largest disk, I forgot how much terabytes you can put inside a disk. Forgot what's the maximum size, because they keep increasing the size from time to time, right? But I know for SSD, I think it's 128 terabytes, the biggest one so far, or 70, is it 72 terabytes, plus minus. But yeah. So disks basically started off from huge guys with less amount of storage space, and they're now getting smaller and smaller but with more storage space itself, right? So this is the trend in the storage environment. I don't know, maybe in the future we'll have very, very small storage spaces. But yeah, but generally nowadays we even see less and less of hard disk drives. So nowadays most of the people are moving towards solid state disks, SSDs, right? Hard disk drives are slowly being removed. The price wise, SSDs used to be very expensive last time, but now the price is getting more and more cheaper. So in terms of performance and all that, SSDs are generally much more powerful and much more reliable compared to HDDs or hard disk drives. Okay, you don't have to remember the dates, don't worry. Then we have the history of SSDs. So solid state drives basically was invented as early as hard disk drives, but it was not used as much during then. It was less reliable then, and it was too expensive, right? It was for the size, 2 MB capacity, probably like 13,000, 14,000 USD or something like that in the old days, right? But nowadays, it's slowly getting much more cheaper in that sense. So greatly lower cost, greater capacity. So now you can find terabytes of capacities on solid state disks. So if you go online and if you check like SSDs, what's the price of an SSD now? So biggest, sorry, let's open up a new one. Largest SSD, let's see here. Oh, we have a 100 terabyte. So as of April 2021, come by solid state drive. This is from Nimbus, I think. Yeah, Nimbus. Okay, but it's 40,000, right? You can buy 100 terabyte SSD, no problem. But one disk is 40,000. So it's up to you whether you want to buy it. You can go ahead with it, but yeah. So this is 40,000 USD for 100 terabytes of disk space on an SSD. Plus, we don't know what kind of SSD is it. Might be multi-level cell or something like that. Might not be that reliable. So basically, SSDs are as old as hard disk drives, but it was too expensive in the old days. Hence, it's slowly getting tracked now. In the early 2000s, it was getting much more tracked because it was generally much more faster, but still very expensive. But around 2010 and onwards, the price has been dropped. The price has dropped very significantly. Nowadays, even home users can use SSDs. You buy a laptop or you buy a desktop and all that, SSDs is a choice, right? Last time it used to be too expensive to own an SSD. Now, 1 terabyte SSD maybe like cost me for 1 terabyte, I think it's about like 200, 300 Malaysian ringgit, right? So it's fairly affordable. Still, the price is a bit steep, but maybe in the future, the price will definitely drop here and there, and we can get generally cheaper SSDs. Okay, oh, sorry, some reason come back here. Okay. Development of flash memory. So this is, we are talking about SSDs. So we're still talking about SSDs. But SSDs, you have cell levels. So you have single level cell, multi-level cell, triple level cell, 3D TLC, but yeah, that's not used as much, and quad level cells. So what are cell levels? Okay, put it into sequence. When you save data into an SSD, you save data into cells. So let's say an SSD has multiple cells. Let's say this SSD has 3 cells. So for single cell level or SLC SSDs, when you save data, you're saving one data into one cell, right? So when you're saving data like this, one data. Each cell contains one block of data, right? Depending on the block size and all that, but yeah. So generally, this guy is the fastest when you save data, because when you're saving data, you're writing data into an SSD. Each block is just one data, so it's just easily just If it finds the block, you just put one data inside, one data, how many MB and all that stuff. Then you have the second guy, which is multi-level cell. Multi-level cell simply means you can save 2 blocks of data into one cell. So each cell can now contain 2 blocks of data. So if you take the previous guy, so if the previous guy, let's say, was 10 megabytes, let's say, right? So 10 megabytes is single level cell. But now if you have multi-level cell, so basically you can save 2 times the data. So now the size has grown to 20 megabytes because each cell can store 1 more extra data, right? And this is how it works. You take triple level cell. So now this guy is 20. So 10, 20. Triple level cell basically means you can save 3 times the amount of data. So basically you can save up to 30 MB, right? So this is how the cell level works. However, for each improvement on cell level, you get more space, but you will have less performance. Single level cell is the fastest performance in all SSD environments. Until today, it's still comparably the fastest, right? There are different technologies out there, but yeah, single level cell is still the fastest. Multi-level cell is more on moderate speed if you compare between single level cell. Triple level cell is what we mainly use now because cater for storage space and viability and all that stuff. Triple level cell is the one that we use in the market. And quad level cell will be basically for extra storage space, right? So quad level cells, you have 4 times the amount of data or 5 times the amount of data and all this stuff. So it's basically depending on the cell level, how much you can save inside the SSD. Single level cell SSD, if you have 1 terabyte of single level cell SSD, it's generally going to be the most expensive SSD you have. Multi-level cell SSD will be a bit more cheaper. Triple level cell SSD is the one you find generally in the market, much more cheaper, and quad level cell is the cheapest in that sense. Of course, there are now newer technologies and all that, but generally these are the ones still used. You can even go online and see for a single level cell SSD, how much is the price? SLC SSD 1 TB. Okay, so you'll see here, this guy is, okay, is this guy, we don't know whether this guy is single level cell, but yeah. Anyway, Amazon will tell us. So how much is the price for this guy? Oops, sorry. No price? They don't tell you the price here? It's about currently unavailable. And they'll tell you. Silicon power. Still currently unavailable. So every single level cell seems like being sold out. Anyways, it will be generally very expensive. It will be about, yeah, about 1,000 is yeah, it's about right. About 1,000 bucks. You can even see this guy going about 2,000 bucks, 4,000, and so on. So that will be single level cell. Generally be much more expensive. But if you say MLC SSD 1 TB, the price will generally be a bit more cheaper. So single level cell will look at around 4,000. Multi-level cell maybe about 2,000. And then you have triple level cell or QLC SSD. QLC will be generally very cheap, right? So you can see the price generally starting to drop because QLC is not that high on performance, and on terms of reliability itself, yeah, not so good, right? Single level cell will have the longest service life. Multi-level cell will have like, yeah, generally moderate, okay service level life. Quad level cell tends to wear out faster because of how it works. Any questions? Hello, sir. Yeah.
Sir, what will the development of the SSD look like in the future?
Sorry, sir. Can't hear you properly. Hello.
Yeah. Hello.
Okay. Yeah. Go ahead.
My question, SSD or XDD, what will the development of SSD look like in the future?
What will the, sorry?
What will the development? What will the development of SSD look like future?
So generally saying what is the problem of SSD and what is the problem of HDD, right?
Yes. Sir.
Okay. Simple. SSD problem, simple. Expensive.
Yeah.
That is the main problem for SSD. So I'll just put it here, SSD. Okay. And we'll generally, if you look at the back, you will have shorter lifespan compared to HDD, right? If you look at the product itself. However, HDD, not reliable. Why? Mechanical parts. So every HDD will have a disk, will have like a what do you call this, actuator arm, read and write arm, and all these things, right? So a lot of mechanical parts in HDD, hence making it less reliable. Even though the lifespan can be longer, but at any time you can buy the HDD today and it spoils tomorrow, right? But if you buy an SSD, because there are no mechanical parts, everything is in flash, they will tell you, okay, if you keep reading and writing data, it can last for this long. It can last for you, if you keep read and writes about IOPS about 1,000, it can last you for 10 years. So generally, they will tell you the lifespan. HDD, they will tell you, okay, if everything runs perfectly, there's no problem, you can keep it running for 30 years. But if like there's too much sun, the mechanical parts fail, if you keep it in a too cold environment, HDD can fail. So HDD is not reliable, right? SSD is much more reliable, but much more expensive. The main problem will be SSD expensive, okay? The compare shorter lifespan, not so much, because generally HDDs don't last more than maybe about 3 to 4 years. If you keep using them every day, 2 to 3 years also can be happening, maybe even 1 month. So I've had a lot of problems with HDDs in my life. I can tell you generally not reliable at all. SSDs, even though you read and write, you have a lifeline, but you at least know when the disk is going to fail. So SSDs, you generally know, okay, my disk is going to fail in another 20 days. But HDDs, you will never know when it fails. Does that make sense, sir? Cool. Is that the question?
Question, sir.
Yeah.
How about the 3D TLC? Is 3D TLC 3 times more space from TLC?
Actually, it's just upgraded version of TLC. So yeah, it's nothing much to talk about. They put it there because it's more for what they call this overlaying storage density and all that stuff. But generally, it's just triple level cell, right?
Okay.
No issues.
So, what is more cheaper and then 3D TLC? Yeah?
Yes, quad is generally more cheaper.
Okay.
Any other question?
Any question?
Yeah, go ahead, sir.
What device example for multi-level or triple level?
So what kind of application would you use for each of them?
Yeah.
Okay, no worries. So this is just best practice, right? So I can't tell you confirm what application you use, but single level cells I will use databases, right? Simple. any kind of huge databases that you want precise read and writes, I will use single level cell. Generally much more expensive, but yeah. For quad level cell, it's be like if you are a gamer and all that, I put all my games here. Because generally I don't need that much. Maybe if you are a gamer, you'll put everything here, but generally I'll just add my games, my application, and so forth. Here, yeah, or your let's say your financial, right? But single level cell, best practices, I will run it mostly for databases, right?
Okay.
Multi-level cell, I will run it more for like your general applications, and then the rest. This one, for quad level cell, maybe I will use it for backup. Right? Make sense?
Okay.
Triple level cell in between, plus minus. Generally, that's how it works. Any other questions?
Okay.
No issues, sir. So hopefully that answered your question, sir. Right. Now we go into interface protocols. So you have, this is disk interface or disk interconnect interfaces. So disk interfaces connect disks to hosts. Interface protocols refer to the communication modes and requirements that interfaces exchange for information and must comply with. So you have parallel interface and serial interface. Generally now you don't even see this anymore. You will not see parallel interfaces. You will see more serial interfaces. This is now the normal standard. So if you still have parallel disks, I think you can keep them for a bit more longer and then probably sell them, can earn a lot of money now. Very hard to find parallel disks, right? But yeah, maybe you can do like collector's edition or something like that. But you will not find them in the market. Or you can still find them in the market, but generally people don't use them for saving anything anymore. It's more of a collector's item, right? We don't use this for actual production environment anymore. Okay. So there are serial and parallel interfaces. Serial is the technology we still use. Parallel is the old technology. And these are the different interface protocols. So the main thing you have to take out is, okay, you have fiber channel interfaces, you have iSCSI interfaces, you have Ethernet interfaces, you have NVMe over Fabric for remote direct memory access, you have fiber channel NVMe, and you have NVMe over Fabric using TCP. And yeah. So for disk interfaces, so these are host interfaces, right? This is basically how your server connects to the storage. So this connection, right? Fiber channel, iSCSI, NVMe, Ethernet, and that's it, right? So you have to remember these four. Fiber channel, NVMe, Ethernet, and of course, I think iSCSI. Right? These are the four major interfaces for host interface connection. For disk interface connection, you have SATA, you have SAS, you have NVMe. Okay? Generally, these are the ones you see in the market. So you have to remember these guys. This is for disks, this is for disks, and this is for hosts, right? So disk interface connections is basically talking about the disk connection inside the server, right? Okay.
I'm sorry, Prophet. Can I ask for a question?
Go ahead.
For the host protocol, so far, which one is the fastest one?
For host or for disk?
For host.
For host, currently the fastest is would be your Ethernet, the 400 gigabyte Ethernet. But the technology is too expensive. So NVMe is currently the leading one.
Okay. And for the disk, for the disk,
it's still NVMe.
NVMe.
Yeah. It's actually called non-volatile memory access. Right? So NVMe is generally the leading guy in the industry for interconnects, but expensive. Everything in storage, expensive. That's it, man. That's the word. So generally, people still use, we still use SAS disks. Why? Cheaper, right? SAS connections. And here we probably use like fiber channel or, yeah, 10 gigabyte Ethernet or something like that, right? 100 gigabyte Ethernet and forward is still expensive. There are some organizations that use 32 gigabyte fiber channel, but Huawei only supports here 16. I think Huawei supports up to 16 gigabyte. I don't know whether they have gone to 32 yet. Maybe they are at 32, but yeah. The last I checked, it's still 16. But in terms of NVMe connection, Huawei does support NVMe, but for very high-end products. For this connection, Huawei also supports NVMe. I think it supports NVMe 1.4 or NVMe, generally NVMe 1.3, 1.4, but yeah. But if you're talking about cost-wise, we still follow SATA, or SAS, sorry. Why cheap, right? NVMe is generally very expensive. You can check it out online, right? All these things, like if I say, don't take my word for it, go online and check out like NVMe disk price. So NVMe SSDs. So for 500 gigabyte, 1 terabyte, how much is this guy? They don't tell you the price. Yeah. Let's check out the price. But generally, NVMe will be much more expensive compared to SAS, right? For enterprise at least. Because when you're buying anything in enterprise grade stuff, you will have the enterprise logo there. So yeah, this one is something I forgot to tell you guys. So like SLC and all that stuff, right? So if in the exam, you might see something like, you'll see A, B, C, D. So which is the question will be, what type of cell levels are there in SSDs? Right? Something like that, maybe, general question. So A might be SLC, B might be MLC, then you have C, might be ESLC, right? So this is where it starts the confusion. ESLC is basically enterprise grade SLC. You also have something called CSLC. This is consumer grade SLC, right? So the E and C do mean something, right? So the answer here will be A, B, C, D, right? Because all of these are cell levels. Just some of them are enterprise grade cells and some of them are just basically normal grade cells, right? So even in the exam, if you see something like, maybe you'll see something like FLC or something like that, there will be a wrong answer. MLC, ESLC, and TLC, right? So the answer will be these three guys. ESLC is a type of SLC, enterprise grade SLC, right? If you see C at the front, so like CSLC, this is consumer grade.
It's mean for ESLC is more faster?
It's not more faster, it's more reliable.
Okay.
So the performance will be good.
How many grades for SLC? ESLC and CSLC. Is there another
The ones that I know is E and C.
Oh,
but they will try to
only two, E and C.
Yeah. So this will be for consumers. So this is something you buy off the shop for your PCs and stuff. This will be for enterprise environments. So this guy might cost like 200 USD. This guy will cost double the amount or triple the amount, right? So generally be more expensive.
It's also for database.
Well,
Definitely.
that is best practices. So yeah. So generally everything in storage is best practice. It's up to you. Doesn't mean that you cannot use CSLC for databases. It's just less reliable. It will wear out faster. So generally you buy ESLC for enterprises, keep it alive more longer. That's all.
Okay.
No worries, no worries. So that's the thing with storage, man. Everything is best practice. It's up to you, no? That's the problem. So like you can ask me what is the best storage. I cannot tell you. Why? Because it's up to your environment. You go and do some checks. Can provide you a few options, but it's up to you. So these are the interface protocols. So if you go back, yeah. Just remember the interface. You have to remember them. We will go through them one by one in topics later on, but yeah. NVMe or non-volatile memory express and non-volatile memory express over fabric. So how NVMe basically works, it bypasses certain layers using the RDMA technology. So you have something called RDMA. RDMA is basically remote direct memory access, right? So using the RDMA technology found with NVMe, it runs together. You can bypass certain layers of the CPU, right? NVMe over fabric is basically talking about generally expanding the disk fabric and all this stuff, right? So NVMe is very, very fast. So it improves the performance, reduce the latency of your random read and writes, reduce the performance between, not reduce the performance, increase the performance of your storage controller talking to your, like say, your servers and all this stuff. But you have to build up the environment. It's been generally a bit more expensive, right? Generally, not a bit, much more expensive than just a normal Ethernet connection. For disks and all that stuff, NVMe over fabric, low latency, high bandwidth, X-ray data transmission among storage network. You will not see NVMe used as a protocol in your local and local network or local area network. You'll only see it in storage environments, right? But of course, in disks and all that, you can see it. Disk connectors like NVMe SSDs and all that, yeah. But the connection, the protocol running on a network, you'll only see it in SAN environments. So you'll not see it in your LAN environment itself. Okay? Don't worry, there'll be another topic talking about this. We'll go through it then. Right. Then finally, we go into development trend of storage products. So history. So history, in terms of storage media, we have grown from SSDs to, we have grown from HDDs to SSDs, or basically what they call the flash architecture. From architecture-wise, we have gone from centralized to distributed cloud storage. This is fusion storage. For management, we went from manual operation and maintenance to intelligent operation and maintenance, or operation and maintenance with some kind of AI, some kind of artificial intelligence. So basically, the more you use the storage system, like Huawei's top-end storage systems, the more you use it, the more it understands how your environment works, and then it will basically learn how your data works. It will basically come more faster, and it will be more efficient in that sense. And then if something goes wrong, it can generally tend to tell you before something goes wrong. Like maybe your disk is going to fail in 30 days. It will already tell you 30 days before. Your disk looks bad. You might want to look at this disk change the disk. That is all how intelligent O&M works nowadays. All the storage systems in the market, the top end ones, generally run some kind of intelligence in their storage system, right? So if you're talking about disks, we're talking about all flash arrays, basically all SSDs. In terms of architecture, we're talking about distributed architecture, so we're talking about cloud architecture. And if you're talking about maintenance, we're talking about some kind of intelligence or some kind of AI interference, right? AI interference, AI backend system learning and managing your products. Doesn't mean that it's like Terminator and all these things. No. This AI product will just basically tend to identify problems before they actually happen, if it can, right? Sometimes problems happen on the spot here and there, but if it can detect, it will tell you beforehand. Okay, like SSDs, they can generally tend to tell you, okay, this SSD is slowly wearing out. You might want to change this disk, right? HDDs and all that, very hard to determine because they run mechanical parts. So at any time they can fail. But SSDs, using the intelligent O&M sequence, they can tell you, okay, we have written on this SSD 3,000 times or 10,000 times. It is going to go wear out soon. You want to change this SSD. Or if there's something wrong with your fan, the fan is running a bit slow, maybe it's blocked, or the connection to your disk. So some kind of intelligent O&M is there. So this is basically where we are looking at. In the future, maybe everything is going to be run by AI, but nobody knows, right? But this is how the future, current situation looks like, sorry. Okay. So the intelligent era is coming. So we have gone through the steam age, we have gone through the electricity age, we have gone through the information age, and now we are entering the intelligent age. Basically, some kind of artificial intelligence environment, right? Everything in industry nowadays, a lot of things actually run on artificial intelligence, like big data, right? Do you realize, when you go to YouTube, the advertisements that come out on YouTube are catered towards you? Like if you are a big fan of like food, like you like to eat food and all that, if you go to YouTube and you watch YouTube videos, there'll be a lot of food advertisements. Do you realize that? Or do you realize the actual YouTube advertisements are catered towards you? Don't tell me you don't realize, right? So these are all things actually done by big data and all these things. So with some kind of back-end analysis, artificial intelligence system, they can tell what kind of user are you. Are you more of a gamer? Are you more of a history buff? Or are you more catered towards like information technology? You like new products, you like new phones? The advertisements and all that are catered towards you. Even the pop-ups and all this stuff generally will be towards what you are doing at the time. So like suddenly if you're taking exams and all this stuff, suddenly the advertisement might come out, exam labs. You can get some questions from exam labs and all these things. If you're like searching previously, maybe like an hour ago regarding food and all these things, suddenly McDonald's will come out. Or even if you like use Grab, right? So you use a lot of Grab and all that stuff. Grab account is basically you're using a Google Play account, right? So you're signing into your Grab or you're signing into your Uber using your Google Play. So Google Play knows like if you went to Grab and then you ordered McDonald's. When you watch YouTube, suddenly McDonald's information comes up. So data and intelligence are inseparable nowadays, right? You'll see a lot of systems using AI. You just don't notice it, right? Even in the work environments, if your company has achieved like facial recognition, intelligent smart campus systems, all these things are already in place. They actually have a Huawei campus in China, whereby everything is run by AI. You come into the campus, like if students come into the campus, generally you just walk through the, like some video camera and stuff. They'll generally tell the class, okay, this student has entered the building, not entered the class yet. If he enters the class, then take but attendance. So the lecturers don't need to take attendance anymore. Everything is done by the system. And if the lecturers want to find the students, they put in the student name. Currently, where is the student in the campus, right? Of course, they don't go inside the toilets and all these things, but generally you know the location here and there. Okay, right. With the new environment, so the intelligent era, there are certain challenges. So what are the challenges? Okay, first challenge, in terms of RAID reconstruction. You have high time consuming RAID reconstruction. This is something that we'll learn later on. High disk failure rate. So if you have a lot of read and writes, you have a lot of disk failure rates. Unstable latency under high concurrency. So if you have concurrent 10,000 connections, you might have latency issues. Insufficient or inefficient converge of block file and storage, object storage. Low data deduplication and compression. So too big file size or too large file size. Too much duplicate data. Service interruption due to multiple points of failure, right? So there are multiple challenges to storage. This is on a base level. Then if you go into the environment level, your storage has to be on 24/7, always on services for all things connected. Latency have to be unisecond level, so real-time high-speed processing transaction for maybe 5G. Total cost of ownership reduction. So that means everything that you own, you're actually using, right? Not something that you own and you're not using it, like DR and all these things. Exabyte level of data. And then there will be another type of challenge, which will be the types of data. So you have so many different formats nowadays. Different applications use different formats of data. There are a lot of challenges in the market. So this can be an exam question. So you need to know just basically what are the challenges faced in storage. Very general, so should not be that hard. Okay. Characteristics of storage in the intelligent era. So basically we're starting with the hardware plus algorithm plus architecture. So robust reliability, device level of 99.999%, easily achievable with cloud. System level 99.999%, solutions with basically on-site and cloud solutions regarding your DR. Large capacity, petabyte to exabyte level of data. High performance, milliseconds to unisecond level intelligent distributed cache. High speed protocols and algorithms, everything in the hardware level. Now in terms of data convergence, zero data migration, converge of SAN and NAS, intelligent storage tiering of hot, warm, and cold. So this is basically what they call smart tier. Multi-level services or multi-service convergence block file and storage. Data collaboration, simplified protocol stack, compute storage collaboration, dedicated hardware. So if you look at everything, where we are going to mainly is cloud, right? Everything leads to the cloud nowadays, right? Storage for AI in storage and all this thing. You can achieve this in your enterprise level, but generally looking more like cloud computing in that sense. More and more people nowadays are moving their environments to the cloud. So in your university environments, do you have any cloud vendors? So maybe like you're using some kind of AWS backend or Huawei Cloud or Microsoft Azure?
I know exactly.
Maybe you don't know, but are you using like some kind of a cloud application, like monitoring your students or something like that? We tend to use Google Drive a lot. We tend to use like OneDrive, Google Drive. All these are actually cloud-based storage, right? So sometimes maybe you don't know. But if you go and check, if you're going and checking on your backend network and all that, some applications might not actually sit on your local environment anymore. They might be sitting in the cloud, right? So, true. Yeah, sir. So characteristics of storage, we can see more and more storage environments moving towards cloud, and more AI-based products are coming out. More and more intelligence on the PC itself, on the product itself. So that's where we are heading. You don't have to remember the whole thing, right? Don't worry about this. no questions will come out from here. But just in case, do go through them, right? Data storage trend. So you have different types of database applications. You have like the x86 based chips, you have the ARM based chips, you have fiber channel, SAS, InfiniBand, hard disk drives. And in terms of distributed storage, you have VM, you have containers, you have IP address, SSDs, and so many different types of storage requirements. You have blockchain requirements, you have big data requirements, general computing requirements, DNA computing, tensor for AI, graph computing for function, brain-like computing for AI and all this stuff, 5G connections. You have ROCs, you have so many different types of storage protocols. So the storage trend is generally growing, right? There are more and more different types of storages or different types of files, and more different types of usages. And generally, yeah, it's kind of getting hard to keep track. But if you want to, like Huawei, if they want to stay efficient in the industry, they have to keep track of all the new storage trends and where storage is leading to, generally more towards cloud, right? So don't worry about it too much. Optical storage technology. So optical storage technology is something that we don't really see yet much anymore. We used to see a lot of like Blu-ray discs, DVD drives and all this stuff, or gold nanostructured. This was something that's supposed to come out, but was just too expensive, right? So using this kind of storages, you can actually keep your data for 50 to 600 years. As long as the disk doesn't fail, as long as it doesn't have scratches, you keep it in a cool environment, you can keep it up to 600 years. But yeah, in terms of reliability, yeah. DNA data storage. So small number of synthetic DNA molecule can, this is a concept, we'll just take it as a concept. So a small number of synthetic DNA molecules can store large amounts of data, can freeze, dry, transport, and store data for thousands of years. Basically, that's how your DNA works. Advantages of DNA as storage media: small size, high density, strong stability. It's a concept, right? Doesn't mean that we actually use DNA to store data yet. But this is something that we are looking at. How to store data, how to make more storage space in so small a space, right? Like your DNA contains everything that you are as a person. How you are growing up, how your bone structure is, what kind of blood type you have, what is your height, what is your weight, what do you eat. All these basically is categorized under your DNA itself, right? If you're more of a, like say a meat eater, or if you're more of a vegetarian, your DNA will have certain files on that. In DNA, you can store so much data in your strand, in a single strand. So we're trying to use, or basically the storage industry is trying to use the concept of a DNA, how we can compact everything into a small amount of space, okay? Bottlenecks and limitation: high cost of DNA molecular synthesis, slow data read and search because of the vast amounts of data. Then we have atomic storage. In 1955, like Richard Feynman suggested that it's possible to use atoms to store information and they could be arranged the way we wanted. Because an atom is so small, the capacity of an atomic storage will be larger than of the existing medium of storage in the same size. With the development of science technology, arranging atoms in the way we want has become a reliability bottleneck, very, very strict requirements. So atomic storage is another concept which can be used but too expensive, right? Because of the strict requirements on the actual environment not being used as much. Quantum storage, like information in electronic devices is stored and moved through flows of electrons. If electrons are replaced by photons, so these are all concepts, right? I don't think they are actually being used, but yeah. So yeah, you can go through it, you can read through it. It's good to know. For exam, no, you don't need it. Right. Then we go into storage network. So how much we have? Okay, a few more only. Sorry. Storage network trend. So as a storage network is what we call a fiber channel SAN or IP SAN. So fiber channel SAN basically uses fiber channel switches. IP SAN uses Ethernet switches. Right? So either way, this is the current technology still being used. Problem with fiber channel SAN and IP SAN is cost. Once again, you will always hear this, high cost, right? Fiber channel is generally much more higher cost than IP, because IP SAN you can use Ethernet switches. Fiber channel SAN you have to use fiber channel switches. But IP SAN has low cost but has poor performance compared to fiber channel. IP SAN is generally a bit more lower performance. But with the 100 gigabyte Ethernet and all that stuff, that performance issues are kind of solved. But yeah, what they're looking at in the future is basically high-end network environment. So probably you're looking about 25 to 100 gigabyte Ethernet network. This is something Huawei is already doing. So Huawei storage controllers can reach up to 100 gigabyte connection. You can buy the card, but can your storage system, can your servers handle it? So if you buy a 100 gigabyte Ethernet card on the storage, your servers are only running 10 gigabyte Ethernet, no point, right? So until the server technology reaches 100 gigabyte Ethernet, which will be very expensive, then we can start using the 100 gigabyte Ethernet. So this is 2B. This is the future. This is basically where we are looking towards. And in terms of operation and maintenance, so IP SAN and FC SAN, you need dedicated personnel, somebody that knows IP SAN or IP storage area network or fiber channel storage area network to basically troubleshoot the product. But future fabric environments, they're looking more on AI-based implementation. So yeah. And it seems to be like the 2B or the Converged AI fabric is mainly looking at data center environments. Because less and less people are actually building actual SAN environments anymore. More and more people are moving towards the cloud. This is just current how it is, right? History. Yep, go ahead. Hello, sir?
Oh, sorry. From a previous slide.
Okay.
For FC SAN, or we use FC switch,
yes,
we use separate network from another network. How about the IP SAN?
Same thing. So IP SAN will still be a separate network. So it will look like this. So this is your local area network, right?
Yeah.
And this is your IP SAN network. So you have your switches and all that stuff.
Okay. So the switch is the same, but we use a separate network, yeah?
Yeah. So the switch for IP SAN, this switch can be used in IP SAN.
Okay.
But FC SAN, no.
Okay.
Yeah. History of storage products. So maybe history of storage products, I will actually go through it in the different chapter, because you will see all the different types of storage products here. You can see Huawei storage products, 2002, dived into storage. 2006, they developed the IP SAN, the first IP SAN for Huawei. In 2008, they launched the second generation FC storage honored by Huawei Simatech. Launched self-developed HSSDs or Huawei SSDs, pioneer in the all-flash industry. First gen smart matrix using the virtual matrix architecture. 2015, second gen high-end storage. 2017, Huawei OceanStar Dorado, fastest all-flash storage actually in the world currently. 2019, AI chips using the Ascend chip and so forth, right? So Huawei, how they started off here. For their all-flash storage and all their unified storage, you can see 2 tracks. So this is for all-flash. And this will be for hybrid storage. Okay. All flash product only uses SSD. hybrid storage, you can use Ssds and SSDs, right? So yeah, Huawei is actually quite powerful in the storage market. A lot of people don't know. Huawei is actually, I think, currently still leading in terms of performance. We'll see that later on, don't worry. But we'll go through both the tracks. So we'll go through all flash, and then we'll go through also the hybrid storages one by one. So for beer, you just understand Huawei has a long history of storage products, right? Not new. From the early 2000s, Huawei has already started developing their storage environment, and they are actually leading in the storage technology in some sense. Architecture of Huawei intelligent data storage products. So Huawei data storage products cater for all kinds of environments. So you have like your single level cell, pod level cell, SSDs. They cater for different types of memory chips, CPU, intelligent scheduling, which we will cover in chapters later on. So all these will be covered in single chapters. So that's why I'm not going to explain much now, because we'll talk about it now, then we'll talk about it again. So it makes it boring. So generally we'll cover this in chapters later on, one by one. Okay, so in terms of intelligent data reduction, intelligent data storage, intelligent scheduling, all these will be covered. Okay. All right. So then at the end of every chapter, usually they'll have some questions. So which of the following are data types? So this is a multi-answer question. Generally, in the actual exam, they won't actually tell you what kind of question it is. So you need to know. So structured data, semi-structured, unstructured. These are the three data types, right? Multiple answer question. Which of the following statements about storage are correct? Maybe you guys can answer this one. Anyone? No? So
Maybe
storage,
all true.
all true?
All the answer are true.
Are you sure, sir? So storage only refers to disk?
Not only.
Yeah, so
Okay. Yeah.
storage system, yeah, correct. Storage types include block, file, object. Yes.
Yes.
File storage is used to store data of data application. Is that correct?
That's right.
There's a bit of a confusing question here.
Yeah.
Yeah. So B and C would be your answer. Actually, you can double check here. I think they do have, yeah. B and C is the answer. So file storage is not only used to store data of data application. File storage is an actual storage itself, right? Oh, there's still some more questions. All right. So which are the characteristics of cloud storage? So this one I'll help you. Converge, open, elastic. Right. Which of the following are objective or integrating AI into storage?
Except C.
Yeah.
Yeah, SSC. ABD. Maybe.
Nothing to do with bad stuff, right? Right. So that's the answer here. So generally, storage questions are not hard. A lot of it on general, what do you call this? General virtualization and all this stuff, right? So in summary, we've gone through the trends of storage, data and information, data storage in terms of storage architecture, storage media interface protocol, and in terms of storage products also. Okay. For more information, you can find them here using the Enterprise Technical Support app or the Huawei Enterprise Service app. Some recommendations in terms of the enterprise website, online learning support, and all these things. And thank you. So that will be chapter 1, module 1, or module 1, chapter 1. Okay. So current time is, let's say, oh yeah, current time is already lunch, all right? So I know you guys are having fasting and all that stuff. So what you guys can do is have a break. So we will, because I've talked for a long time, so we will take a bit more longer break. So we'll be back at about 1:15. Is that all right with you guys?
Okay.
So just an extra few, because Usually before lunch, I should give 30 minutes break, but yeah, did not achieve 30 minutes, only achieve 15 minutes. So we'll be back at 1:15 p.m. Okay.
Okay.
So rest yourself now, and then we'll continue later on.
Before that, can I ask some question?
Sure. Go ahead.
Yeah. Because I forgot to ask.
No worries.
Yeah. It's related to distributed architecture. I would like to know what happens if all the nodes are down, or all the nodes in distributed architecture are down.
Okay. So you're talking about the data.
Yeah. Is there any warning from the storage management or anything, or what will the storage management do if all nodes are down in distributed architecture?
So if you're talking about all nodes down, there are only one sequence that can happen there, right? So basically, if you have multiple nodes in an environment and all of them go down at the same time, basically it's a power outage, right? Most likely. So unless the whole data center goes down, this will not happen. And usually, even if it's a power outage, you'll usually have generators and all this stuff. But however, if all the data all the physical environment goes down, basically data is lost. But yeah. Go ahead, sir.
It doesn't have any backup plan, so it doesn't.
So in cloud environments, you usually build HA. So what you'll do is they have the concept called availability zones, right?
Okay.
So you have something like AZ1 and AZ2. Sorry.
Okay.
AZ2. Okay. So this is just cloud environments. So AZ1 and AZ2 will be basically two different data centers, two different physical locations. Okay. So what will happen is you'll have data here, and then you'll have something called disaster recovery, DR, here. So your data 2 will be here. So this will be an active passive environment. So if the whole environment goes down, basically your data is migrated in data 2 and then can continue working.
Okay.
But that is cloud environment. So
yeah. Okay. Thanks.
No worries.
Yes,
no worries.
Yeah.
No worries. Any other questions?
Yes, I saw on the Excel, maybe on the next few days, we will learn more detail about data recovery system, right?
Yeah, definitely.
Okay, thanks.
No issues. Anytime, sir, anytime. Right, any more questions? Else you guys can go and take a break, no issues. We'll be back 1 hour later.
Okay, sir. Thank you.
Thank you, sir. Thank you.